match problem 1, we're given a function z equals f of x, y, all this, and what we want to do is calculate the derivative of that function with respect to y. Once we have that derivative, f sub y, then we want to evaluate it at x equals 2, y equals 3. So one trick when you're taking derivatives like this is to kind of help yourself realize that anything that doesn't have a y is just a constant, is just to go term by term through this and just scratch out anything that doesn't have a y. So 2x squared, we're treating that as just a constant since we're differentiating with respect to y. 2x squared becomes 0. This has a y, so we leave that alone. This has a y, leave it alone. But then the derivative of 1 is also just going to be 0. So for our derivative, we only have to worry about negative 3x squared and plus 5y. So here we have both x and y that are occurring in the same term, but x squared is still just being treated as a constant. So the derivative of negative 3x squared y, or the derivative of a constant times y, will just be negative 3x squared. And then the derivative of 5y will be just 5. In part B, now we want to take this derivative function and substitute our values for x and y. So this will be negative 3 times 2 squared plus 5, which will give us negative 7. So part B is not really the trick here. Part A is of just kind of getting familiar with this idea of differentiating with respect to, in this case, y instead of x, and realizing that all of these x's, even though they are a variable, that when we go to differentiate with respect to y, we just treat those as constants.